Okay, for today's lecture, we will learn on how to find eigenvalues and eigenvectors. So first, we go to the definition. Consider the matrix n by n, meaning it's square matrix. So the eigenvalue lambda, okay, denoted as lambda, and eigenvector denoted as x, are defined by ax equals to lambda x. So x is said to be an eigenvector corresponding to eigenvalue L. So if there are, lambda. If there are 3 lambda, meaning there are 3x corresponding to the lambda. So the first step is we need to compute the determinant of A minus lambda I. Okay, or A minus lambda I, the determinant, okay. So I is the identity matrix. So if it's 3 by 3, so it should be identity of 3 by 3. So we need to find the roots of the polynomial, the second step. So here we will let it equals to polynomial of lambda. Okay, so we will let it equal to 0. We can find the roots. So we'll get lambda 1 equals to what, lambda 2 equals to what, and lambda 3 equals to what. So if we have lambda 4, we find lambda 4. So for each lambda here, we will find the eigenvectors by solving A minus lambda I times I equals to 0. So we will look at the example. Okay, now the example 1 is to find the matrix or the eigenvalues and eigenvectors of this matrix A. So it's a 3 by 3. So first of all, you need to write A minus lambda I and find the determinant. So A minus lambda I, so lambda I is equals to lambda times the identity matrix. So that's why we get this. So A minus lambda, you will get this answer. So from this answer, we need to find the determinant. So determinant, we will use the first column. So it will be 3 minus lambda. So we delete the first column and first row. So it will be negative lambda times 2 minus lambda minus 0. So that's why we get 3 minus lambda. So it's actually like this here. So in the end, we just have this. Okay, so this is the polynomial. So this is what we call polynomial of lambda. So 3 minus lambda, negative lambda, and 2 minus lambda. Okay, so now we will proceed to the second step. Okay, now the step number 2, we will write polynomial and let it equal to 0. So here we can also write like this: negative lambda, 3 minus lambda, 2 minus lambda equals to 0. So be lambda, so we separate one by one. 3 minus lambda equal to 0, 2 minus lambda equal to 0. So when we solve this, we get lambda 1 equal to 0, lambda 2 equal to 3, and lambda 3 equals to 2. Okay, so now for each eigenvalue, so this is what we call eigenvalues. Okay, lambda 1, lambda 2, lambda 3 is the eigenvalues. Now for each eigenvalues, we need to find the eigenvectors. Okay, so to find the eigenvectors, we use this. A minus lambda I times x equals to 0. So we'll find for each eigenvalues. So for the first one, lambda 1. So so the original one, we have A minus lambda I is equals to 3, 6, negative 8. So 3 minus lambda 0, 0 minus lambda, 6, 0, 0, 2 minus lambda. So this is a general a minus lambda I. So now we know the value of lambda, so just substitute 0 on the lambda. So that's why we got this matrix. So for lambda to equals to 3, we will substitute lambda 3. Lambda equals to 3 here. 3, 3, 3, 3, 3, 3. So we get 0, 0, negative 3 and negative 1. So when we get the a minus lambda 1I, so we will find we write in the form 3 minus this one in this form, a minus lambda I times x equals to 0. Okay, the same thing for lambda 2. Okay, lambda 3. So now we have the equations to find the eigenvector. Now we will need to solve each of these 1, 2, 3 in order to get the eigenvector. So how are we going to solve this? You have learned on how to solve system of linear equations of 3 by 3 matrix. So here we will use Gaussian elimination. So, okay, we will start with lambda 1 equals 0. So we will reduce the system before by using Gauss elimination. So we see at the end we will get 0, 0, 0. So meaning this system has many solutions. So from this one we can write second row x3 equals to 0. x3 equals to 0. So x2 we let it equals to s. So then we look at the first row. Okay, when x3 equal to 0, so 0 here is s. So that's why it's become x1 plus 2s. So x1 must be equals to negative 2s. So we write x1, x2, x3. So now you have the answer. So x1 is negative 2s, x2 is s, x3 is 0. So, or you can factor out the s. So you will get this. So this is the eigenvector for lambda 1 equals to 0. So now we'll continue with the next one, lambda 2 equals to 3. Again, we will reduce using Gauss elimination. So again, we get many solutions here. 0, 0, 0, meaning it's many solutions. So from the second row, we get x3 equals to 0. Okay, and then from first row we get this one, so go to 0, so the equation just left with 0 x1 plus x2. So here x2 must be equals to 0 since the coefficient of x1 is 0, so x2 must be equals to 0. So what is x1? So we can just let x1 equals to s, any real number. So we get x1, x2, x3. So it's equals to s0, 0. So if you factor out the s, you will get answer like this. So that's it for the second one. Okay, now we'll proceed with the last eigenvalues. So lambda 3 equals to 2. So we'll reduce in using the Gauss elimination. So we get this answer. So we will write from the second row, we will write x2 minus 3x3. So we get this answer equals to 0. So x2 must be equals to x3. So if we let x3 equals to s, okay, x3 equals to s. So we substitute s here. So we get x2 equals to 3s. So from the first row, we will substitute x2 3s, so here s, so you get the answer x1 equals to negative s. So when you write x1, x2, x3, so it's actually negative 10s, 3s, and s. So if you factor out the s, you'll get the answer s equals to negative s times negative 10, 3, and 1. Okay, that's it. So we have obtained 3 eigenvalues and 3 eigenvectors corresponding to each eigenvalues. So I hope all of you got this. Thank you very much.